If you ever get the chance, you should walk into a half-built house. It's all just studs and open air. But what you're really looking at, it's more than just wood. It's this beautiful, silent machine. And it's designed for one single purpose: to fight a never-ending war with gravity and win every single day. So how does this incredible machine actually work? Let's get into it. And that's really the big question here, isn't it? When you think about everything nature throws at it, how in the world does a simple wooden house manage to stay standing? Not just for a year or a decade, but for 100 years or even longer. Because, and make no mistake about this, everything out there wants this house gone. Gravity is constantly trying to flatten it into a pancake. Wind wants to shove it over. The actual ground it's sitting on wants to swallow it whole. And moisture, well, moisture is always trying to rot it from the ankles up. It is a relentless 24/7 battle. So why does it win? Well, it's because a house isn't just a pile of lumber. It's a structural skeleton. I like to think of it as a wooden exosuit. And it's held together with some really clever geometry, a whole lot of physics, and, yeah, maybe just a little bit of hope. So today, we're going to peel back the drywall and take a look at the bones of this thing. Okay, so the very first fight a house has isn't with the wind or the rain, it's with the ground. Before a single 2x4 gets cut, you have to make a deal with the earth itself. And honestly, the earth can be pretty picky. It all comes down to some really simple physics. A house weighs an incredible amount. That's the load. And you can't really change that. So what do? You have to increase the area. Builders use this one simple formula to keep a house from literally sinking into the ground. It's called the snowshoe principle. Right, so if you just put the walls directly on the soil, they would stab straight into the dirt like chopsticks into mashed potatoes. It would be a disaster. But with a foundation, that same enormous weight gets spread out over a huge area, and the ground can handle it no problem. It doesn't panic. It's such a simple but absolutely genius solution. So how does the house actually— hold on. Well, the foundation is physically locked to the very first piece of wood. That's called the sill plate, using these J-shaped bolts that are set right into the wet concrete. And that sill plate is pressure treated with chemicals to fight off moisture. It all comes together to create this perfect, permanent handshake between the earth and the entire structure. All right, with that handshake firmly in place, we can finally start building up. So let's move on to the floor, which is the beginning of the home's ribcage. Now, any floor has to support two different kinds of weight. First, there's the dead load. That's the constant weight of the house itself, its own bones. Then you've got the live load. That's everything else. It's you, your family, all your furniture, and yeah, even that treadmill you swore you were going to use this year. Back in the day, old houses used solid pieces of lumber for floor joists. And they looked great, but they had a tendency to warp, twist, and squeak over time. Modern construction, though, uses these engineered I-joists. Think of them as the college-educated cousin of a 2x10. They're straighter, they're stronger, and they're way more reliable. So no more bouncy floors when someone walks by with a bowl of soup. And now we go vertical. The walls, they are the true rib cage of the home. They're built with these vertical boards called studs, and they're usually spaced exactly 16 inches apart. It's kind of like this construction jazz rhythm that standard sheets of plywood and drywall are all designed to match up with perfectly. Now, if you ever look closely at the top of a wall frame, you'll see there aren't one, but two boards running along the top. So why a double top plate? Well, here's the thing. Gravity is rude. The load from the roof doesn't always line up perfectly with the studs underneath, so that second plate is crucial for spreading the weight sideways. It also has a second job. It overlaps at the corners to lock the whole house together into one solid, rigid box. Okay, think about this for a second. A solid wall is fantastic at holding things up, right? But the second you need to cut a hole in it for a door or a window, you're basically committing structural assault. You've just destroyed the direct path that gravity wants to take to get to the ground. So what do? We have to build a detour for gravity. Above every opening, we install this really strong beam called a header. The header catches all the load coming from above, shoves it sideways over to these supporting jack studs, and those studs carry the weight safely down to the floor. It's literally a bridge, telling gravity, sorry buddy, this lean's closed. All right, let's move up to the hat of the house, the roof. And this thing is not just for keeping the rain out. Oh no, it is a masterpiece of structural engineering, and it all comes down to the absolute genius of one single shape. So, old school roofs used things called rafters. They were strong, but they had this one really bad habit. When they got a heavy load, like a bunch of snow, they wanted to push the walls of the house outward. Not good. Modern homes use these prefabricated trusses. They're engineered to direct all of that weight straight down, not out. And the secret? It's the shape. Trusses are just a bunch of triangles. And triangles? Well, triangles are the bouncers of the geometry world. They are incredibly rigid, and they absolutely refuse to change their shape when you put them under pressure. They are stubborn. And let me tell you, in construction, stubborn is a very, very good thing. Okay, so we've figured out how to conquer the vertical bully, gravity, but now we have to deal with its much more chaotic cousin, lateral force. This is the sideways punch that comes from things like heavy wind or, even worse, earthquakes. If a house frame doesn't have protection against these sideways forces, a strong shove can cause it to do this. It's called racking. All those nice, sturdy rectangles that make up the walls deform into wobbly parallelograms. This is basically a geometric crime, and it is very, very bad. The solution, believe it or not, is surprisingly simple: sheathing. By nailing big sheets of plywood or OSB to the outside of the studs, you create what's known as a shear wall. This layer of wood freezes the studs in place and transforms what was a flimsy, rackable rectangle into an immensely strong, unshakable box. So, let's put it all together. Imagine one single snowflake lands on the roof. Its tiny, tiny weight starts a journey through the ultimate obstacle course. It travels from the truss to the double top plate, down a stud, through the floor diaphragm, to the sill plate, into the foundation, and finally, it's deposited safely into the earth. It is a perfect continuous load path. Every single part of the house is doing its job in this silent cooperation. It's like a chain of custody for gravity. It really is a wooden exoskeleton. And the amazing part is, it never ever sleeps. So the next time you see a house being framed up, don't just see a jumble of lumber. See the system. See the intentional, elegant engineering that was designed from the ground up to win a constant war against the forces of nature. It makes you wonder, right? What other everyday objects are hiding this level of genius right in front of our eyes?